Thank you. Thanks for having me. Yes, so let's get going. I've got a lot of content to get through. So we're going to talk about pushing WebRTC up that broadcast hill. So I'm Dan Jankins. I'm a WebRTC and real-time media geek. I've only really just recently come into this space. I'm more a WebRTC person. And I run a company called Everycast Labs with a product called Broadcast Bridge. And I also organize a conference in the UK, which is coming up in 2 weeks' time. So Everycast Labs, we have a product called Broadcast Bridge. We bring remote collaborators into your professional workflow very, very simply. But let's talk about pushing WebRTC up that broadcast hill. WebRTC is 12 years old now, and it's barely been a thing within broadcast. So how many people in the room, very, very quickly, have heard of WebRTC? Everyone, great. How many people have actually done something with WebRTC and not just bashed it? Very, very few compared to, that's kind of what I expected. So that's great. So let's define WebRTC. WebRTC allows two peers to connect to one another, and it doesn't matter whether or not they're behind NATs or firewalls, etc. And it uses a process called ICE to be able to do that. I'm not going to talk about what ICE is because it would take a long time, and I don't have a lot of time. I've got 140 slides to get through in 20 minutes. So WebRTC allows for media and data to be able to be sent over this peer connection. But the very, very big thing about WebRTC is that it's encrypted by default. And a peer doesn't have to be a client. A peer can be a server, can be an SFU or an MCU. Again, I'm not going to tell you what an SFU or an MCU is. I haven't got time for that. But it's a server. It does stuff up in the cloud. And WebRTC media is actually sent as RTP, which is hugely powerful just in itself, because that allows for RTP extensions to be used. Whether or not that's RTX, whether or not that's absolute capture time, whether or not that's audio levels, whether or not that's absolute send time, video orientation, playout delay, video content type, and there's loads more. So it's really, really flexible that it's built from a foundation of RTP. It's a really great tool set to have. And some in this space may say it's rather prosumer. There's a link to a tweet there that you can all go and have a look at afterwards. But in order to understand why someone might think that WebRTC is prosumer, we need to take a look at WebRTC and WebRTC's past. So Google acquired a company called Global IP Solutions, who essentially built WebRTC, but then they open sourced WebRTC. They then chucked that into the IETF and the W3C, and they were involved in standardizing the whole thing, which is great, right? We don't want to build off of stuff that isn't necessarily standardized across an industry. But at its very, very core, WebRTC was designed for conference calling. And conference calling is basically real-time media on the web. And anyone that's been on a conference call would go, well, this isn't broadcast quality. This is glitchy and packet loss, and because we're doing things in real time. So yes, that's true, but it doesn't have to be true. The trouble with the IETF was that the process was led by VoIP people and not necessarily video people, because at the end of the day, it was real-time media. And so real-time media equals web real-time media, which kind of equaled VoIP. And this led to lots and lots of decisions, like using SDP to handle negotiation of a session. How many people know what SDP is? Half of the audience, that's great. So yeah, that's a questionable decision, but it made it happen in the first place, which is great. But the biggest decision, at least in my mind, was that there was no standardized signaling method. And this meant that people could use whatever they wanted to, whatever was right for their application, whether or not that was JSON over WebSocket, whether or not that was SIP over WebSocket, XMPP, GraphQL, some other proprietary format over WebSocket or HTTP. And you can times that by, a bajillion. You could do it your way. You could make it work for your application, whatever was right for you. Whether or not you wanted to include the SDP in your messaging, or whether or not you wanted to get rid of it and fill it in either side. More and more, one of my friends called Gustavo, he recently did a blog post, which I didn't link to. I'll go and change these slides before I upload them. He did a blog post about all of the providers and how they transport their signaling and whether or not they include SDP or not. So lots and lots of players out there in the real-time space are getting rid of SDP and kind of filling it in either side. So that works too. But no signaling standard really kind of isn't ecosystem friendly. Like WebRTC was built so that it was actually built so that like you could connect a WebRTC call in a browser to a VoIP call. That was kind of one of its big superpowers. But annoyingly, there was no standard for signaling. So we've got all of these other standards, and they mostly just work, right? Because they mostly just work because there's this standard for setting up that session, right? But the lack of common signaling was great and bad for WebRTC. It was great for us in the web world because it meant we could build what we wanted. It was terrible for people wanting to kind of build encoders and decoders that just knew how to kind of just send a stream somewhere, right? You didn't want to have to build an integration into, say, Dolby or whatever, like a bajillion times to be able to support the whole ecosystem. So, yeah, that lack of common signaling wasn't the only issue. So let's take a look at the main issues that people have with WebRTC. So lack of controllable latency, that's a bit questionable because you can kind of ish control it. Lack of encoder decode support control in a browser, and lack of control generally. Like if you're in a browser and you ask for a stream and you say, I want 60 frames per second and this and that, well, you're not actually going to potentially get 60 frames a second because of X and Y and Z. You've got very, very little control of what you actually end up with. So you've got to pray to the browser gods. But WebRTC has its own superpowers. And that is the fact that it works in a browser. It works on billions of devices across the globe without you doing anything. You can get a new iPhone or you can get a new Android phone today. You can open up the default browser that's already installed on that device and open up a URL and you'll be able to connect to a service. That is a superpower. Without installing a thing, you can address lots of people, but you can also get media from lots of people. So you've got to use the right tool for the right job, and WebRTC is the right tool for the right job. It might just be a different job than you might expect. So let's look at today. So yeah, I said it works in all the browsers, even mobile. Safari, Chrome, Firefox. Edge is a clone of Chrome, and so is Opera to a degree. So let's not talk about them. So it supports new codecs, AV1, H.265. Can they really be called new anymore? I don't know. Supports Opus Red in Chrome. So if you don't know what Opus Red is, it's redundant audio, which means you can send multiple versions of that audio. And so even if you hit packet loss, you're going to get good audio. It means you're sending more data, but at the end of the day, we don't care. We've got the audio that we wanted to. And it's more than just libWebRTC. At the very beginning of WebRTC, libWebRTC was the de facto thing, and that was the only thing that was included everywhere. Firefox, not really true, but they still used kind of parts of libWebRTC as well. So there's loads of other libraries out there that have their own complete WebRTC stack. So there's Pion in Go, there's WebRTC Rust, there's AO RTC, Pipe in Java, and that's just a couple of them. So it's really quite powerful. You can go and build what you want to today. SVC allows us to encode video kind of once into multiple things, which is really quite powerful. But the support of it is different in every single browser. We've got simulcast, which means that we can encode a video multiple times to be able to get multiple qualities. So kind of the same, but kind of not. But again, the different support is, the support in every browser is very, very different. And X and Y generic features, but they're different in every browser as well. Can you get where I'm going with this? The superpower is that you can use WebRTC in a browser on billions of devices, but the support in every single browser isn't the same. Scaling isn't simple. This is a thing that comes up an awful lot. Scaling to hundreds of thousands of people, connections, devices, yeah, it's tricky. And it's really expensive because you can't just say, oh, here's a manifest file with a load of media, let's just, stream it out. I'm not saying that's easy by far, but imagine creating hundreds of thousands of peer connections which are individually encrypted, sending out media. It's really, really expensive to do it right. So yeah, WebRTC's present is really, really tricky. But let's get to the exciting bit. Something is coming, something has come that's going to make all of this far, far simpler. We've got standardized simple signaling now. So there's a protocol called WHIP, which is the WebRTC HTTP ingest protocol. And then we've also got WHEP, which is WebRTC HTTP egress protocol. I really want to change the name of WHIP to ingress so that I don't mess it up when I'm on stage every single time. But yeah, they go hand in hand. So what is WHIP and what is WHEP? So let's take a very quick look at WHIP, because they're both very similar to one another. At the heart of both of them is this HTTP post request. So this is the post request. It's going to an endpoint, WHIP endpoint test. Thank you very much to the Me Echo team for writing very good blog posts that I could take this snippet from. And so it's a post request to a URL, and it's got some SDP in it, and it's got a content type of application / SDP. And then the server, which doesn't have to be your media server, can be any HTTP server. As long as it knows what's going to be dealing with your media, you can scale this completely horizontally away from your media. So this is the response from your WHIP request. So you get 201 created back, and it tells you, here's the location of your resource. You'll notice that is different to where I sent the request. And application SDP and a load of SDP gets sent back to you as well. So you create your offer in the browser or on an encoder or whatever. You send it up via an HTTP post request, and then you get back an answer with an answer. You get back a response with an answer, and then you shove that into your browser as an answer, or your decoder or whatever, and you get a peer connection. So you get one HTTP request, and that allows you to create a connection. There's lots of other parts of the protocol in terms of reconnecting because of network change, et cetera, et cetera. But at its very core, it is this simple to get going. You don't need to create a WebSocket that lives for an hour because you're on a call for an hour or whatever. You get one HTTP request up and a response, and you're done. WHEP is exactly the same. Not quite exactly the same because you're dealing with receiving media, but it's the same concept. It's really, really, really simple. And that means ecosystem friendliness, right? And this is the thing that I talked about earlier. We don't have to build integrations into 1,000 different companies, whether or not that's Wowzer, Dolby, whatever, Cloudflare. We can just build once and it work. And this is fantastic. So WHIP and WHEP are getting industry support. Dolby, a company called Millicast actually made the standard for WHIP, and then Millicast was bought by Dolby. So Dolby have kind of been pushing that forward, which is absolutely fantastic. But we've got other companies as well. Cloudflare, with Cloudflare Streams, supports WHIP and WHEP. We've got Osprey, Talon encoders. They support WHIP. OBS has got a pull request open for adding WebRTC support in with WHIP, and then I expect WHEP support to kind of follow that. Flowcaster, LiveView, and lastly, my product, Broadcast Bridge. I've got to put it in there somewhere, right? What's coming in WebRTC's future? Or what do I hope we'll see soon, because no one truly knows what's coming next. Web codec support. I really wish this is coming soon. I hope it's coming soon. So anyone that's kind of been paying attention to technology in the browser will know that we've got web transport and web codec. And web transport is this thing that's going to, save us from the evil that is WebRTC. It's not. It's taken us, 12 years to get to this kind of point with WebRTC. Web transport isn't going to be on every single device across the globe for many, many years to come. So web codec support with WebRTC would allow us to kind of independently from what was baked into the browser, build our video and audio streams ourselves, take back some of that control. Dread, deep audio redundancy. This has kind of come up recently from the Amazon team, and it's really, really exciting, so I hope we see this very, very soon as well. But ultimately, I want to see bringing all the browsers up to the same spec. Right? We have a spec for a reason. I mean, that's not going to happen, is it? I mean, this is a web problem generally. It's not a WebRTC problem. Web creators, web browser creators, take a spec and kind of build from it and then kind of iterate on it, which is great. Like, you get something really quickly and you can play around with it, but then like you're left with this half-dead something for years to come until someone finally decides to implement it properly, or just let the thing die. Yeah. So what's in it for all of you? Why would you pick up WebRTC today? I mean, lack of control, issues scaling. I mean, you're not really selling. I'm not really selling it to you, am I? No. But I mean, ultimately, WebRTC really is a right tool for the right job, and you just got to find the right job. Don't shove a round peg in a square hole or whatever. Like, it will work well for you. You've just got to figure out what that thing is. Right? WebRTC isn't necessarily right for broadcasting to 100,000 people. I mean, you can. There are companies out there doing it. Dolby, Millicast, Cloudflare. They've all proven you can do it. But, like I said, it's expensive. So, like, why would you do it? You might do it if, like, I don't know, people were watching a betting thing and they really needed to be, like, within, 60 milliseconds of what was being broadcast. But for 99.99% of things, you would never do it, right? It just doesn't make any sense. WebRTC isn't right for transporting media within a studio. This is another thing I hear quite often. Why would you send media within a protected network over WebRTC? You wouldn't do it. You'd use one of those other transport mechanisms. WebRTC is really right for real-time collaboration. It's got the lowest friction to being involved. You don't need to go on an app store and download Zoom or one of the other players. You just open a browser, you get sent a URL, you tap on it, it opens your browser and it works. Super, super simple. It's the power of the web. WebRTC is right for weird network scenarios. If you know that things are going to be weird, then you might not want to, say, set up an SRT stream, right? WebRTC is perfect for this. Like I say, it's a tool in the tool belt. And even though web browsers frustrate me a lot, it is WebRTC's superpower. It works absolutely everywhere. Not everything needs to be a nail being hit by a hammer. You might just want a nice precision screwdriver that does a job really, really, really well. I've seen stranger things than WebRTC being used in broadcast. And that's me. Thank you very much for having me. Clicker, thank you very much. And thank you.